I've never heard you be that quiet.
I'm gonna have a stroke doing math.
First problem. Like I said, I want to get to as many as I can. So, these are pulled from various years' AP exams. You'll see that there's a lot of similarities between them. They all fit into similar categories. They'll all talk about a particle. So, let's start with number 5. The velocity of a particle, v of t, is given by the function v of t is equal to t squared cosine of t plus 2. If the position of the particle at t equals 2 is 10, what is the position when t equals 5?
Take an integral, then you have the point so you can plug it in and answer.
Yes. So the trick of this one is being able to take an integral. Now this is from the calculator portion, so you can actually integrate this one, but you'd have to have boundaries when integrate. That's the issue. So this one, let's talk about the actual integral itself. We have, so as a reminder, to go through what Michael just said, I have the velocity function v of t. The question asks about the position function. In order to go from velocity to position, we need to integrate. That is the basic process we go through every time. Remember, to go from position to velocity, we differentiate. To go from velocity to position, we integrate. So from here, I know we have the integral of t squared cosine of t plus 2 dt. And we don't have any boundaries because we're not trying to determine like an area. We're trying to determine what the function itself is. So we have to make sure this is an indefinite integral. But then we're left with this equation, t squared cosine of t plus 2, and we're told to integrate this thing. How are we going to integrate t squared cosine of t plus 2? So broad full use substitution, not a bad way to think about it. Okay, not a bad way. So if we're going to do that, we would need to first look at this thing and say, how can we do a use substitution? So what's my u going to be? What do you think? Sure, let's try that.
I'm just going to make the entire thing cosine t plus 2.
Well then, would the derivative be in the problem? We always want to try to use one that either has a derivative in the problem or offers a way to rewrite it. So, if I choose my u to be equal to t plus 2, then I need to also make sure I know what my du is. So what would my du be? dt. So let's replace. This would become the integral of, so cosine of u du is all agreed upon. But there's no way to get rid of the t squared. So one of the techniques we might use is to rewrite t in forms of u. So we take this u, subtract 2 from both sides. This would become u minus 2 equals t. And now everywhere there's a t, I can replace with u minus 2. So that means that the t squared becomes u minus 2 squared. Well, let's pull that cheat sheet out. Do we actually have an integral that will fix this problem? Yeah. Okay, save it, send it to me. Nice.
Yeah, I don't really care.
Okay. How'd you do this? Okay. Do you have it saved still? How to do it?
Yeah.
Okay. Send it to me. I'll work on it tonight, okay? Okay, so.
Would you split? No, but like you go back and like split it.
Splitting the multiplication becomes very, very, very tough.
Okay, never mind then.
I'm staying out here so I can do it.
We
Also,
should do it. We should.
what are the odds that I
You
can
know,
get
this may be less efficient, but honestly, I think it's really trying to find.
Maybe. What did you say, Michael?
It may be less efficient, but I think it's easier to just grunt, just full force instead of place count trying to figure out how to do it.
Okay.
As terrible as that sounds, I think I'd rather boil it out and try and find a.
Okay, so let's break down some things. So if we come across a problem, like let's say you're on the AP exam right now. you come across a problem, you're like, I know what I should do, but I'm having difficulty doing it. Can I at least eliminate some bad answers? Can I at least eliminate some bad answers? What do you think?
Well, that negative.
You think they're negative?
Yeah, I mean, it's a negative position.
That can happen.
Yeah, it could happen.
So what they're saying is that at t equals 2, it's gone from here over to 5, or sorry, over to 10. So it could just turn around and come back.
What I'm saying is like it's the outlier amongst positive answers. It's a better way to
Yeah.
in my mind anyway.
Yeah. That's
It could
True.
be, oh, wait. It's testing me whether you got the positive or negative right, so it must be A.
It turns out the answer is A. Okay, so
It's so
okay, how could I let's see? How can I talk about this? What I could do is investigate what's happening to V. Because remember, V is the velocity. It tells me the change over time. So if at 3, 4, and 5 the velocity is positive, that means my number would have to keep getting bigger. Right? Because my position would have to keep getting larger because the value of the velocity is big, so I have to keep getting larger. If it gets a little big, then we know it has to be close to 10. If it gets a lot big, you know it has to be farther away from 10. And so we could use that to like assist ourselves in the problem and then make a reasonable guess. Okay? Because in these kinds of questions, like that's kind of what you got to do if you get to a problem. Because you're going to have problems with this AP exam where you're just going to be like, we may have gone over it, but I don't remember it, or maybe it was just something that we just didn't talk about. Like you don't know, or maybe it's just something that doesn't fit with everything else, or you're just panicking. You got to look at it and go, okay, can I at least narrow this from 5 options to 4 to 3, 2? Like anything to narrow this list down will be worth a little bit of time. So what I did for this problem was I looked at it and said, I don't think I can do that integral, t squared of cosine of t plus 2. To do it, you have to actually use something that's normally discussed in Calc 2, referred to as UV substitution. It's an interesting concept.
Oh, wait, I actually did that on one of mine.
Yes, it's actually a neat way to do the problem. And so, but when I looked at it, I was like, okay, if I don't want to do that, my best bet is I look at the function v of t and say, okay, is this function going to be getting larger or smaller in this range? And it turns out when t is 2, if I plug in 2 for my velocity, 2 squared is 4, cosine of 2 plus 2 will be cosine of 4. Cosine of 4, that's a little bit bigger than pi. That would tell me my velocity is actually negative. Because when cosine is bigger than pi, we get negative velocities. And so like I can use that and be like, okay, so the velocity is clearly negative at 2. What about 3? On 3, I get cosine of t plus 2, so that'd be cosine of 3 plus 2, so cosine of 5. Cosine of 5 is between pi and 2 pi. So again, it's going to be down here where again, cosine is negative, but it's slowly becoming positive. In the fourth quadrant, cosine starts to become the dominant one. And so by the time 4 comes around, cosine of 6, that's clearly in this quadrant. Cosine of 7, that's actually in this quadrant, where again, the velocity should all be positive. And so it's a little negative, but then it gets bigger. And so I can eliminate d for sure, but it's not getting that much bigger. When we get to 5, we get 25 cosine of 5 plus 2, so cosine of 7. That is 25 times 1 point that, so that'd be 27, give or take. I could go a calculator and type that in and see if it's actually really close. And see, well, which of these actually makes the most amount of sense? Well, I started off negative, I slowly got to positive, and I ended pretty largely positive. So I could look at it and rationalize, okay, does that mean I'm going to be staying near 10? Does that mean I'm going to be far away from 10? And at least I can eliminate some options. Okay, that's the big thing with these kinds of problems. Is if you're not sure what to do, eliminate a couple options, circle an answer, move on. Okay, use logic and reason to do so. On this first one, answer was actually A. 3. Let's try it again. A particle moves along a straight line with velocity given by the equation v of t is equal to 7 minus 1.01 negative t squared at time t greater than or equals 0. What is the acceleration of the particle at time t equals 3? So I'm given a velocity equation and asked about the acceleration.
Derived.
I have to take a derivative. How do I know that, Michael?
Yeah, the velocity goes to acceleration. Acceleration is just the change in velocity.
Good.
Yes.
So if I have a velocity and want to get to acceleration, I have to take a derivative. So now this question becomes, can I take a derivative of that expression? Well, let's do it. V of t is equal to, this is number 5, is equal to 7 minus 1.01 to negative t squared. If I want to determine the solution, I need to take a derivative. So we're going to take a derivative with respect to t. Okay, well, this was from chapter 5. Can we take a derivative of an exponential function? Let's start with the easy stuff. One piece at a time. At first, I start taking the derivative of 7. What is the derivative of 7? 0. So the acceleration function is equal to 0. Now, the derivative of an exponential function. Well, I have 1.01 to the negative t squared. Now, from the exponential functions, you always multiply by a constant and use the chain rule. So let's talk about the chain rule first and the constant second, because chain rule should be an obvious one, because I have a function inside of a function. I have an exponential with something above it. So the negative here, I'm going to have some kind of constant, which I'm going to leave blank for right now, times 1.01 to the negative t squared, times chain rule. I got to multiply by the derivative of the top piece. The derivative of negative t squared, negative 2t. This become negative 2t. Not subtracting t, negative 2t. So my acceleration equation, so I have a negative and a negative making this positive, so I have 2t times 1.01 to negative t squared, and then I'm missing a constant. For this problem for exponential functions, what is the constant? You don't remember? Cheat sheet? Cheat sheet. The derivative of an exponential function, so a to the x power or a to the u power.
Oh, is it 1 over natural log of?
Okay. So this becomes 1 over natural log of 1.01 times 2t times 1.01 to the negative t squared. So I now have the acceleration equation. Yay! But that's none of the answers. What did I do next?
Write in F equals in the circle.
Big brain. Big brain. F equals me.
F equals this.
Okay? So we want to find the acceleration at a specific time. So that means I want to find a of 3. So I do a of 3.
Yeah,
So 1 over ln 1.01, 2 times 3 times 1.01.
Our Calc teacher, so we don't have to simplify stuff.
That's a beautiful answer to me.
Like it's exact. Isn't it exact?
yeah,
Most
it's correct.
So I can estimate some here. So ln of 1.
That's very close to 0. So I'm gonna say
Yes.
it's insignificant. So 1 over. Just pretty much.
But 1 over something that is close to 0 makes it very, very large.
Right.
So I would guess that a calculator, the answer is E. But let's test it out. Let's see if it's actually right.
There's not, and E's not up there though.
E, the answer.
Oh.
So I applied logic. If I don't have a calculator, this is kind of how you have to do it. We look at it and say, okay, ln of 1 we know to be 0. So if I look at this problem and say, okay, ln of 1 is 0. So that means I have a number 1 divided by something close to 0. We talked about with limits that when you divide by something close to 0, it goes towards infinity. This first number is getting very large. Times 2 times 3 is 6. Times 1.01 to the negative 3 have a 3 squared power. Make sure the negative is in the right spot.
Yeah, I tried to. Did I miss another negative or
No?
0? Because I plugged it in, I'm getting like 500.
Where is this line 6 coming from?
Times 6, 2 times 3.
Oh, okay. I see it.
Yep, everyone's right.
Is that?
That's a nice solution.
I may have told you the wrong. I thought it was A to U. Yeah, no, it's just A to U equals natural log of A. Times
Oh!
Apologies, I mixed it up with.
Michael! Michael!
You all fell for it. Same as me.
Ah, Franks.
Franks. I mixed it up with the derivative or with the integral. Dang.
Yeah, you did.
Dang it.
It's okay, because when I was looking at that one, I'm like, I remember this one in a really long time. I was like 80% sure. I was like, I know there's another A in here somewhere. Okay, so now if I don't have a calculator, I have ln of 1.01 that is very near 0. So I have 0 times, or something near 0 times a bunch of other stuff. But they're all positive pieces. So I'm going to guess now that my answer should be B. It is.
Did we have a question like this in the test?
Yep, we did.
Yep. Just E is a magic number. God's number. God's number is always right.
So as Abby was so keen to point out here, yeah, there's a lot of formulas to learn. Okay?
Oh, you heard that?
Yeah.
Oh.
I ain't
I
dead.
feel like you hear everything.
I got some pretty good hearing. I just tend to ignore a lot of it.
Oh no.
I have terrible
Oh, dear.
hearing.
Okay.
Okay.
Questions at number 3. So the first couple of steps have to be done correctly before you can even bother doing the actual math. I have to recognize that I have a velocity function. Recognize that in order to find the acceleration function that involves a derivative, be able to take the derivative correctly, and then plugging in 3 as the last part with the calculator assistance. Now this was a calculator problem. So, alternatives I could have done. Since this is a calculator question, I could have used the calculator to solve the answer. I could have typed in the derivative with respect to x of this function at 3 and got the solution. As a reminder, almost all calculators that you will take into the AP exam have the ability to do a derivative at a value. So for mine, I come in here, line it in the math tab. Come on, turn on, baby. Thank you. I go to math. I want to find the derivatives. That's the nth derivative, so I hit 8. It's going to ask me a couple things. I want to take this with respect to x. And I'm going to type in my equation, 7 minus 1.01 to the negative x squared. And then I want to set this up with x equals 3.
Yeah, pass again.
Whoop, there it is.
I do.
Let me show you where to do that real quick.
Oh, yeah, I know.
A couple things. Most calculators, if you put a negative sign instead of a subtraction sign, have issues. Like, make sure in the problem, are you supposed to be using a negative sign or are you supposed to be using a subtraction sign? And put it in correctly to match.
It's really funny because last year, the Calc students on my old school, they weren't allowed to use graphing calculators on like just their tests that she gave them.
Yeah.
And one of my best friends was in that class and he didn't have time for the calculator, so I let him borrow mine, but it had derivatives on it, like he did derivatives. And so now he came up to me every single time he took a test to take my calculator and I go, what the heck?
I don't think I ever used a graphic calculator for the class.
It's not really that helpful for a lot of these. On the first one, it would have been a little helpful because you could have looked at the velocity and be like, oh, clearly it's doing these things. But like even then, it's still not great. Okay, 4. A particle's position is given by the function p of t is equal to 3t plus 4.1 sine of t for t greater than or equal to 0. Find the total distance that the particle travels on the interval. So now we have to reach in deep because back in chapter 4, we talked about how to find something called displacement versus distance. There was a formula for it. If you remember that formula, then this problem's easy. If you don't, it becomes very difficult to even start it. Now this formula is on your cheat sheet.
Oh, it is?
Yes, or at least the idea of it is. I think it's under application of integration.
Just
It's just the total distance.
Yep.
Okay. It's the integral from A to B.
Number 4, hold on. Integral from A to B.
And then absolute value of V of t. And then dt.
Is that correct?
Yes.
Okay.
that's a lot easier than plugging the distance.
So, A and B
Going at it?
is 0, that's A, and then 2.5.
So far, you are correct.
I'm so smart.
Then we have to take the derivative of the position function.
Essentially, V of t is the same as P of t.
No. V of t is the velocity function, P of t is the position function. Michael is correct here. We have to take a derivative to use this formula. Now, here's a neat little trick here. Because eventually, I'm going to have to undo that derivative.
So the answer would just be the same.
But here's the problem. We're integrating the absolute value function, not the original function. So it's good to look at the derivative, specifically because there's a chance that at some point in time that derivative becomes negative. And if that's the case, we need to adjust this formula a little bit. So let's go ahead and take the derivative. What do you get for the derivative?
Oh god, give it a second.
3 plus
Yes, that.
4.1 cosine.
Let's take
Oh, I just saw the 3t plus 4.
That's all I saw. And then I was like, oh,
what are
wait a
you
minute.
talking about?
Okay? DT. So when we talked about absolute value functions, don't forget that we can break this apart into multiple versions wherever it crosses the axes. So if you have a graphic calculator, what I recommend doing at this point is graph that function on the inside, 3 plus 4 cosine of t, and see if it is ever negative between 0 and 3.5. If it is negative at any point in time, we need to take this function and break it apart. If it's not ever negative, then it turns out we can actually just drop the absolute value symbols. Remember, the absolute value's sole purpose is to convert this from positive to negative. If it's never negative, absolute values don't do anything. Here we go. I want to graph this function now. Pull out my graphic calculator. Thank you. Y equals the following function: 3 plus 4.1 cosine of t, in this case cosine of x. I'm looking for specifically any places where this function could be negative between 0 and 3.5. So I'm going to zoom down a little bit. In a second, I'm going to zoom in. Focusing on between 0 and 3.5. If there is ever a time where it is negative in between those values, I need to take that into consideration when I'm doing this integration. I'm going to zoom in. Go to zoom standard. Between 0 and 3.5. So 3.5 is right about there. Is it ever negative in between? Just for a little bit of time. Yes, it is. Now, here's the trick. Wherever it is negative, there's a simple way to get rid of an absolute value symbol. As a reminder, wherever it is negative, there's a simple way to get rid of an absolute value symbol. Here we go. Go back to my notes. This is one of those things that, because there will be a displacement question, if you don't remember how to get rid of an absolute value symbol, this is something you should add to your notes for the AP exam. The absolute value of some function is equal to. Now, I'm going to declare that there is a boundary point somewhere in here. Let's call it A, where A is the place where this function changes from negative to positive. So, at A, f of x equals 0. At all values less than A, f of x is negative. And for all values bigger than A, f of x is positive. I have to declare it this way because I have to have some kind of change happening for the negatives to do anything. So what happens? Well, this turns into a piecewise function, broken into multiple components. When it's positive, the absolute value is just going to drop. When it's negative, I have to introduce another symbol into the problem. This becomes the following equation. It becomes just f of x when it's positive. So whenever I'm positive, there's no change. The absolute value doesn't matter. When I'm negative, the absolute value puts a negative in. So what this will do is it'll force this equation to become positive. Wherever it used to be negative, it will now be positive. So
you're just going to take 2 equals?
I need to split this into 2 integrals. One for just the positive components, and then a negative version just for the negative components. But to do so, I need to know where it's negative. Let's take a moment. I'm going to go back to the graph here in a second. I would need to figure out where this function has a negative value. Come on. There we go. How can I figure out what this function is a negative value? Okay, calculator. What?
You're gonna use the Calc button.
Yep, that's what I'm going to do. I want to figure out when this thing turns negative, right? That would be where it crosses the axes, or in algebra we refer to as a zero. Well, guess what? The calc command lets me find zeros. Now there are a lot of zeros in this picture, so I want to make sure to isolate the correct zero. And I can use it at the same time to be like, hey, is this value actually going to be there? So it looks like it's somewhere around 2.4, which is in this range. That tells me it's a good one to look at. I also want to check this one that's over here to see if it's also in this range. If it is, then I have to turn it into 3. Here we go. I go over a little bit more to the right. At 3.6, I'm not on the axis again, so I'm just going to focus on this first one. So I go to the left of it, go to the right of it, I get the value. It tells me it happens right about there. 2.3916197. So what I'm going to do now is I'm going to take this integral and split it into 2. This becomes the integral from 0 to 2.3916 plus the integral from 2.3916 to 3.5. Now what happens to the first piece? Well, in the first piece, the function is positive, so there will be no change. Meaning, I'm going to integrate 3 plus 4.1 cosine of t exactly the way it is. No absolute value symbols anymore. Just integrating. I keep trying to draw a parentheses, and I'm drawing a straight line, which means I'm looking at absolute value. There we go. What about the second piece? We need to negate it. Instead of plus, I can either put a negative here or change it to a minus. But I need to negate this and do 3.41 cosine of t dt over here. Now, because it's a calculator, the calculator can do this. So that's what I would do for this problem. I'd plug this piece in. Just have the calculator work out 90% of it for me. Now, alternatively, I could remember that, hey, the original equation was already the integral of this thing. And so I could plug in 0 and 2.3916. I could plug in 0.23916 and 3.5 and see what it is. Otherwise, the calculator will do it for me. Okay? Don't make the negative symbol. It will throw your answer off. And as you type that in for me, I'll be going over here, pulling the answers back up, and seeing if we can actually match to one of them. Ooh, yeah. Ooh, yeah. So, as you're typing in, a quick note. Indecision is the devil in the AP exam. You have 60 minutes for 30 questions. These questions take time. If you spend 2 minutes trying to figure out how to start the problem, you've already used all the time you have for that problem. So one of the things that can help you best practice for the AP exam is to be able to look at a problem and decide quickly what you need to do. And if you're wrong, being willing to go, crap, move on. Just take a guess that you think is the best possible guess and move on. Because you have 2 minutes of question. That is not a lot of time. If you go in the wrong direction for too long, you'll have not only wasted the time for this question, but the next question too. And so deciding quickly, okay, I need to integrate, let's do it. And then going and doing it. Versus, oh, I need to get rid of it. Oh, I chose the wrong one. Crap, we just take a guess and move on. Like, that's like worst case scenario. Now, if you are a kind of person that stresses a lot in the test, I'm sorry. I can't help that. There's no way to fix that for this kind of test. Like, I don't know why the AP exam is timed, if the goal is to know how much you know. In the real world, no one cares if you can do calculus fast. They care if you can do it well. But for some reason, the AP exam is not proud of those times.
Because they're greedy.
C.
The answer C? Beautiful. Now, there are other answers in here. You'll notice that there's some duplicates in here that could probably tell you that the AP exam probably made a mistake, and that neither one of them is probably the solution. Now, the other examples on here actually are some neat things. I believe this first one is actually just this integral by itself. And I believe this last one is if you just do this integral without the parentheses, without the absolute values. Now, fun fact, the reason I went through this manually was because it's important to know. But I believe your calculators have an absolute value function. Then you could have integrated it with the absolute value function instead and gotten the answer. Try it, please. I know my TI does, but it's kind of hidden. So I'm going to do this exact same problem now. But either way, I can't do this problem unless I can take the derivative. And I remember that, unless I remember that there's supposed to be an absolute value symbol in there. And even then, if I remember those two things, then I can type it all into the calculator and get the solution. But if I do it by hand, that's just going to take more time. Here we go. I'm going to integrate, so we go to math. I'm going to do an integral, so number 9. The integral is from 0 to 3.5. I need an absolute value symbol. That should be under either math or test. I don't remember which, so I'm going to check. ABS is absolute value. There it is. I type in 3 plus 4.1 cosine of x dx. Oh, that's 41. Oops. Let's go back and fix that. Okay. 3.1. Does I get 10 point whatever?
It's taking a while on mine.
Yeah, it does.
The,
Because it has to figure out the same things we figured out.
10.8.
the absolute value is also under the alpha window. Yeah, it's one.
The alpha window?
Yeah.
Ah, look at that. Learn new things. But yeah. Now, if this was a non-calculator problem, you couldn't use this trick. You have to know to break it up this way and just follow the way.
It's disgusting when you put it by hand.
The way to do this by hand is they wouldn't give you the velocity function, they give you the position function. That way you save a step, not having to take the derivative. And it'd be an easier one to separate out. Because like finding 2.3916 by hand, no, it can't be done. You end up with a cosine inverse in your problems. You can get the answer, it is not an acceptable answer. It's cosine inverse of negative 3 over 4.1. And so when you plug it in, you get, the answer has that number in it. That's super annoying and irritating. But then instead use a number that's probably on the unit circle somewhere. Next problem.
Can I give any tools to use on AP test?
Never one that I've seen. So whenever I go to the AP exam, the first thing I did was, because they give you some time to log in and stuff. First thing I did, I drew a full unit circle, and every rule I could remember, I wrote down. Because they give you some pieces of paper, right? Every single rule I could remember. I don't want to have to sit there and be question 25 on the test with only a few minutes left and be like, shoot, what was the grade of EX? Your brain's toast by then. You're going to spend 5 minutes trying to remember that stupid derivative and then be like, oh, I'm an idiot. 5 hours later, you go, derivative EX. As much as I can physically put down, especially the difficult stuff, the stuff that is hard to remember. The product rule we've done enough times, I might skip that one because I know it well enough that I could do it, but you might feel differently. The quotient rule is tougher, so I might put that down. The chain rule, the U versions of a lot of them, a lot of the fancier integrals, those ones I definitely put down. This displacement one, I'd put down, and right next to it, 4 displacement problems, or 4 total distance problems. Don't just write in the formulas, write what they're used for. You have time before you walk through that door to write stuff down, put as much as you can onto that cheat sheet. I'd recommend practicing making that page. Practice, if you want to tell them what could be good practice the night before, don't sit there and try to do a bunch of problems, because if you're good at them, it's not going to help you, and if you're bad at them, it's going to discourage you. Instead, just look at it and go, okay, Here's my cheat sheet. Go through the entire thing. Go through the entire thing. Go through the entire thing. Okay, put it down. Grab a fresh sheet of paper. Everything you can remember, write down. Draw a full unit circle. Take a breath. Take a breath. Take a minute. Pull it back out. Check. How much was right? Because we use the formulas enough that if you have the right formula, many of you guys can get the solutions, and I have great faith in that. That's not the issue. It's going to be, can you remember the right formula? Can you then take that step? I'm also going to showcase next week a couple of shortcuts to limit some of the problems to make them a lot easier, especially the limit problems. There's a couple of nice limit tricks that we haven't talked about. One of them is called L'Hopital's rule. It makes the limit much easier to do if you know how to use it. Like, literally takes half to a quarter of the time. And so, like, we'll talk about some of those tricks and stuff next week. This week we're just focusing on physics. Next one. A particle moving on a straight line so at any time t greater than or equal to 0, its velocity is given by the following equation. For which of the values of t is the particle speeding up? Ooh. So now I have to understand what this is asking me in terms of the physics. What does this say? For which of the values of t is the particle speeding up? What does that mean? It means it's asking about the acceleration, specifically what about the acceleration? What does speeding up mean in physics?
Positive.
Like positive acceleration. This question is asking me, when is acceleration greater than 0? If I can't take that step on my own, this problem is impossible to do. So, now I know that this problem has to do with acceleration. I have the velocity function. I have to take the time to figure out what it's asking me. Now I need to know, how do I find the acceleration function?
Right.
I gotta take a derivative. Now, this would be one that's a unit circle question and will not be on the calculator portion. Because it expects you to be able to plug in pi over 6, pi over 3, and 2 pi over 3 into the equation using the unit circle. Now, that being said, in this class, we'll let it happen. I had to take a derivative of this function, which you notice is sin of t on top, cosine of 2t on bottom, so I can't simplify it any more than it already is. I'd have to use a quotient rule to get the acceleration equation. And once I have that new equation, what would I want to do next? Plug in pi over 6, plug in pi over 3, plug in 2 pi over 3, and look for what specifically?
Positive values.
Positive values. Do I care what the actual value is?
No.
I care if it's.
Positive or negative.
So that is helpful because if I don't necessarily remember all the values, like I can ask myself, do I think this will be positive or negative? And I can use some methods of mathematics to figure out whether the answer is going to be positive or negative. I'll leave this one for you guys to try on your own tonight as homework. Number 7, please try on your own tonight. There are only, I think this was the last one, the first one. Nope, there's a couple more. And the rest are pre-response ones, so you can do some of those as well. Okay, this is the homework for this week. I'm going to try to go through as many as I can tomorrow. If you are not going on the trips for Earth Day, you're welcome to stay. I'm working with, I'm telling you, like, if you want to work on some calculus stuff, you're welcome to stay.
7-1 extra lesson? Or 7-2?
I will be going through as many of these as I can. Any other questions anybody wants to ask?
I turned in 7-1 and 2.
Yeah, I'm going to turn in mine as well last night.
I will go through more 7-2 when I ask.
Bring the tears.
Alright?
Bring the tears on us. Oh, but I did it.